Hi! Welcome to the video presentation of Group 2. And now, we will discuss about the hexagon in nature. But before that, let me introduce to you my group member first.
Hello everyone, my name is Ryan B. Tumuwanwa from Section Delta.
Hello everyone, my name is Walfred G. Cagulada from Section Delta.
Hi, I'm Juliana Claire Magalo Tagan, 18, first year BX Criminology, Section Delta, from Southwick College of Technology of San Francisco at San del Sur.
Good day everyone, I'm Renijin Bulala Antikia, first year criminology from Section Delta.
Good day sir, my name is Christian T. Fabiania, first year criminology, Section Delta.
Hello classmates, hello Sir Plata. My name is Melbourne T. Dumanga II from Section Delta.
Hi everyone, my name is Edwin Balboa, first year criminology from Section Delta.
Hello everyone, my name is Vanessa Alipalibang from BS Criminology of Section Delta.
Good day everyone, I am Joshin Ken P. Joseph, first year BS Criminology from Section Delta.
Good day everyone, especially to our subject teacher, Sir Plata. By the way, my name is Genevieve Nama from Section Delta.
And hi, it's me, John Ryan Emrofon, from Section Delta, the group leader of Group 2. So, let me ask you a quick question. When you hear the word hexagon, what comes to your mind first? Of course, you think about the shape and what kind of shape it is. Of course, hexagon. And how many sizes are there in hexagon? Yes, it has 6 equal sides. But in an irregular hexagon, the sides are of unequal length, and its internal angle can be more or less than 120 degrees. Regular hexagon can be used to pack the most number of units into a flat plane with no wasted space and with a minimum perimeter. Hexagons are not only commonly found in nature, they are also found in various types of human designs and digital displays. But don't you know that hexagon in nature exists? I know, a lot of us already seen a lot of things, a lot of art that is very related to this hexagon shape. But we didn't just notice it. So now, let me discuss to you the various different examples of hexagon, just like the honeycombs, snowflakes, the compound eyes of various insects, benzene, and other cyclic compounds, and certain types of minerals are among the most well-known examples of hexagonal structure in nature. First is the honeycomb. Honeybees weld their own honeycombs with wax they produce, so they need a form that makes the most efficient use of this precious wax resource. The regular hexagon fit these requirements, allowing bees to fit the most cells into honeycomb. Their hexagonal cells are nearly the same size with the same precise wall thickness across height. The purpose of this honeycomb is to the hexagonal shape to have an space, just like the space and stability. Second one is the snowflakes. Of course, the laws of physics are also at work when six-sided snowflakes form. Depending on the weather conditions, snowflakes often begin as small regular hexagonal plates, formed by water molecules as they freeze. Because each of the hexagonal internal angles is 120 degrees, such a split has an unusual stable structure. As the split tumbles through the clouds, exposed to different temperatures and levels of moisture, crystal arms grow from each of the 6 outside corners. When all corners are exposed to the same condition, the arm grow into the symmetrical crystal seen in some snowflakes. I know we don't have a snow here in the Philippines, but in the movie, I guess, we have seen a lot of snowflakes in the movie. The third one, of course, is the turtle shells. The scutes or plates on the backs of turtles often form a hexagonal pattern. Yes, the arrangement of these bony plates help protect the turtle volatile organ while enabling flexibility and movement. And the last one is the basalt columns and other minerals. One of the most striking examples of hexagonal structure in minerals are basalt column, as they seen in the Devil's Postpile National Monument in California and the Giant's Causeway in Northern Ireland. Basalt columns are formed by lava outflows that cool and begin to shrink. The shrinking creates surface tension that produces cracks into the basalt, and turns out that cracks at 100 degrees release the most tension. Gradually, the cracks create the hexagonal columns of basalt. Most of them are irregular. If all parts of the lava had cooled at the same rate, the basalt columns would all be regular hexagon. I know there are still different examples of what do you call this one? Different kind of examples of hexagonal pattern or hexagon in nature. But let my members others discuss all about it.
So first question is, what concept is fully discussed on your assigned video? The discussion is all about hexagon in nature. The hexagon is one of the geometric shapes found in nature to which esoteric power has been ascribed. In geometry, a hexagon can be defined as close two-dimensional polygon with 6 sides. Hexagon has 6 vertices and 6 angles. Also, hexa means 6 and gonia means angles. Second question is, what is about this concept? Cite few more real-world case or example that would show the concept. We live in a world where shapes meet substance, and geometry forms an inseparable part of things around us. The example of this is honeycomb, nut, snowflakes, tie knot, and also pencil base. Number 3, the last question. What are your insights about these mathematical truths or certainties? My insights about these mathematical truths is relies on logic rather than our observation, as its standard of truth. It employs observation, simulation, and even experimentation as means of discovering truth. That's all. Thank you.
Number 1. What math concept is fully discussed those video? The Fibonacci sequence is the main mathematical idea covered in those videos. It describes the operations and inventiveness of the Fibonacci sequence. Number 2. What is about this concept? Cite few more real-world cases or examples that would show the concept. All of these ideas revolve around the patterns and sequences that exist in our environment. Fruits and vegetables, similar spiraling patterns can be observed on pineapples and cauliflower. Spiral galaxies. Spiral galaxies likewise follow a spiral pattern. These are only a few instances or real-world cases that would demonstrate the principles. The well-known Fibonacci sequence. Number 3. What are your insights about these mathematical centuries? Although mathematics uses simulations, experimentations, and even observation as a technique of truth finding, it relies on logical rather than observations and its criterion of truth. At first, I believe that the Fibonacci sequence exclusively dealt with patterns and numbers. This made me realize that natures follow a sequence as well.
So what math concept is fully discussed on your assigned video? So hexagons are polygons. With 6 sides that possess properties, they have sides of 10. Angles measuring 120 degrees, which classifies them as regular polygons. Hexagons can be observed in formations, such as beehive cells and geological structures, like the giant causeway. These examples highlight their ability to efficiently pack space and occur naturally in our surroundings. Next question is, what is about this concept? Cite few more real-world or examples that show the concept. So in the real world, hexagons are often associated with packing and optimizations. They naturally appear in context because they provide the effective way to carve a 2D space with uniform shapes. Take beehives for examples. The hexagonal cells found in beehives maximize storage capacity while minimizing the amount of wax needed to construct them, making them energy efficient for bees. Similarly, the basalt columns at the giant causeway take on shapes due to the process of cooling and cracking, which reduces stress and energy consumption. In this way, hexagons found in nature symbolize a blend of stability and research efficiency. So the last question is, what are your insights about these mathematical truths or certainty? So hexagons found in world offer us a glimpse into the realm of mathematics, revealing patterns that are both efficient and consistent. These geometric wonders boast 6 sides of length, angles measuring 120 degrees, providing a mathematically assured distribution of space and resource much like the cell within a beehive. Natural formations such as basalt columns further exemplify how nature strives to minimize energy expenditure and stress, resulting in the formation of symmetrical patterns. Through this example, we witness firsthand how mathematical principles serve as a backbone for optimizing and organizing our surroundings.
I will answer 3 questions regarding our video about the hexagon nature. Number 1 question: what math concept is fully discussed on your assigned video? So, hexagons are 6-sided polygons and they have several mathematical properties and concepts associated with them. It is interior angles, exterior angles, regular hexagon, area, perimeter, symmetry, and diagonals. These are some of the fundamental mathematical concepts related to hexagons. Number 2 question: what is about this concept? Cite few more real-world cases for examples that would show the concept. For me, my example to the real world about the hexagon nature: number 1, honeycomb structures. Honeybees use hexagonal cells to build their house. The hexagonal shape makes efficient use of space and allows for the storage of honey, pollen, and larvae while requiring the less amount of wax. Number 2 example: turtle shells. Some turtle species have hexagonal scutes, the individual plates that make up the shell, which add strength and flexibility. Last example, number 3. Soccer balls are made up of 20 hexagonal and 12 pentagonal panels that are stitched together to form a spherical shape. Number 3 question. Last question. What are your insights about these mathematical truths or sentences? Okay. My insights about hexagonal nature: it is the hexagon is an intriguing geometric shape that can be found in a variety of natural and man-made phenomena. Because of this mathematical truths and properties, hexagons are a fascinating subject in mathematics, geometry, and a variety of scientific disciplines. Their distinct properties have practical applications in architecture, engineering, and crystallography. So that would be my answer.
Number 1. What math concept is fully discussed on your assigned video? However, I can provide information about the mathematical concept related to hexagon in nature if you'd like. Question number 2. What is about this concept? Cite few more real-world cases or examples that would show the concept. Hexagons are often found in natural patterns like honeycomb structures and some crystal formation due to their efficient packing and symmetry, which minimize energy and maximize space usage. Question number 3. What are your insights about this mathematical truth or certainties? This is closely related to concept in geometry and mathematics like tessellation, Voronoi diagram, and hexagonal lattices.
Question number 1. What what math concept is the hexagon in a nature. So concept in hexagon formula, it calculates the perimeter, area, and the diagonals of the concept. And question number 2 is what is about the concept. So in the real world, the hexagon is surprisingly present in many parts of nature, like columns of basalt from an old volcanic eruption and the snowflakes. In the last, what are your insights about the mathematical truth or certainties? So for me, it is like a logical and no arithmetic in a mathematical way, because mathematics seeks to discover and explain about abstract patterns or regulation of all kinds.
What math concept is fully discussed on your assigned video? The fully discussed on the assigned video is all about the hexagon in nature is an efficient shape for packing identically shaped cells together. Number 2. What is about this concept? Cite a few more real-world cases or example that world show the concept. The world show the concept or the example of the concept, which is also how many shapes and the also part of shape around the use. Example of the hexagon nature is a honeycomb, a football, piece of pencil, and floor tiles. And lastly, number 3, what are your insights about these mathematical truths or certainties? The kind of truth you get in the math is rather low level of truth. Whatever extent they are able to pass truth in at the beginning, math allows one to derive consistent result.
Question number 1. What math concept is fully discussed in third video? The math concept that is fully discussed about hexagon in nature geometry. Hexagons are 6-sided polygons that are commonly found in nature. Geometry is the concept that is fully discussed about hexagon in nature. Question number 2. What is about this concept? Cite few more real-world cases or examples that would show the concept. Here are the examples for this concept that is real case. Corals, the skeletons of some corals are made up of hexagonal structured leaves. Bees build their hives in hexagonal shape, which is an efficient way to conserve energy. Question number 3. What are your insights about the mathematical truths or certainties? Mathematical truths or certainties are fundamental concepts that are universally accepted as true in the field of mathematics. For me, mathematical truths are based on logical reasoning and independent of personal beliefs or opinions. Mathematical truths are consistent and can be applied in different contexts and situations.
Hexagon in nature. Number 1 question. What concept is fully discussed in your assigned video? It was all about the hexagon in nature, its parts, types of hexagon, and what is hexagon structure. What is hexagon in nature? And some structure that describes the hexagon in nature. Number 2 question. What is about this concept? Cite few more real-world cases or examples that would show the concept. Some example of real-world cases of hexagon in nature is honeycomb, snowflakes, the skin of a giraffe, and the compound eyes of some various animals. Number 3. What are your insights about the mathematical truths or certainties? Mathematics is not all about numbers, but it was also about everything in nature. It enriches our understanding and appreciation of the natural world.
So overall, hexagon in nature demonstrate the beauty of mathematical patterns and the efficient use of space. From honeycombs to rock formations to snowflakes, nature showcases the versatility and elegance of the hexagonal shape. That's all guys, thank you for watching!